Now let's turn to oversampling and asymmetric costs. Oversampling is done when your data set has very few events. Okay, so you have like 10,000 records and only 100 of them are events, or something like that, which can happen, which is not uncommon. So in that case, in order to have a good size train data, you may want to do oversample the events rather than using stratified random sample. So stratified random sample will be like if there are 10% events and 90% non-events, then you want to take a train data from that, say 70% train data, then you go to the events, take 70% of those, you go to the non-events and take 70% of those, then you have a 70% train data. But now if you do that when you have very few events, then your stratified data will reflect the original data in the same proportion for the events against non-events. But then there will be very few events that the model will have tough time capturing the underlying relationships. So instead of just simply going by the exact same proportion in the underlying data, you take more of that. So you take all of the events, okay, and then get equal number of non-events. So now the train data, instead of being 10%, 90% event to non-event like in the original data, you'll have 50% event, 50% non-event. So now you have lots of events, so your model will have easier time figuring out the relationships. So this is called oversampling. So when you have oversampling and asymmetric costs, then how do you adjust for these changes that you have incorporated into the structure of the data? So rare cases, okay, so some examples, responders to mailing. So you send out mailers and only 1% of them respond. So that is a rare case. So some the fraud and fraudulent transactions. So these are rare cases. So if you go by the naive method, then you will then classify everybody as a legitimate, every transaction as a legitimate transaction. You won't catch anybody. So in those cases, you have to do oversampling. So typically use 50% of ones and 50% of zeros, even if the underlying data has very few ones, right? So that's oversampling. So oversampling procedure, separate events and non-events, right? Responders and non-responders. So separate them. So randomly assign half the responders to the trained sample, or half, or maybe even 50, 60%, 70%, whatever percentage that you want to leave out for the validation set. The remaining you take, and then take an equal number of non-responders and put them together, and that will be your trained set. Okay. So assume that misclassifying O, okay, so now asymmetric cost comes in. Cost of misclassifying O is 5 times the cost of misclassifying X's. So now oversample. Now you're now going to oversample. All right. So the previous case was oversampling rare events. So now we can apply the same concept of oversampling when you have asymmetric costs. So if O is 5 times more expensive, more costly when misclassified than X's, then you oversample the O's to incorporate asymmetric costs. So sample 5 times as many O's as we would to get the simple random sample. If there are not enough O's as in option 1, then you do sampling with replacement. So when you do sampling with replacement, then you can build up the number. Option 1 is preferred, but if you don't have any choice, because you don't have enough data, then you sample by replacing the ones that you've already sampled. So here, classifier, so all of that is classified as O, all of these are classified as X. So now assessing the model performance, score the model with the validation data set selected without oversampling. So now to to validate, so your trained set is now oversampled, right? So now you have a model. Now you want to calculate performance measures for the model. So one option is to set up a validation set that reflects the underlying data. That is not oversampled. The validation data set has the same proportion as the data set, then you apply that. Okay. Or if your validation set is also oversampled, then you have to make some adjustments. Method 1 is straightforward and easier to implement, but you may not have that luxury always. So you may have to end up with having oversampled validation also. So in which case, how do you adjust for the performance measures? Okay. So here is an example. Suppose we have responders and non-responders, 2% and 98%. Okay. Then validation sample is 50-50. Okay, this is oversampled. So now the weight is you divide the underlying data percentage into the validation percentage and you get the weight. So validation sample is 25 times greater in weight than the actual data. For the responders and non-responders, it is only about 51.02% as the actual data. So once you have these weights, then we can use the weights to adjust our classification matrix. So if this is the classification matrix that we developed using our 50% validation, oversampled validation data set, then if you don't adjust for the fact that we have done oversampling, your misclassification rate will be 190 divided by 1000, so 19%. And the percentage of records that are predicted as 1 is 53%. But this is misleading because the validation set is oversampled. So now you have to take these weights and use these weights to adjust your or reweight your classification matrix and then compute the misclassification rate. So let's look at this example in Excel. Okay, so now let's assume that this is our classification matrix like the one we saw right here. So total okay, so then the misclassification rate then is that plus that divided by that is 19%. Okay, remember again, this is misleading because the validation set is 50%. So now we have to adjust for that fact and we need to so we take the actual zeros, right? So this divided by that weight. Okay. Now we're going to have to copy this. So we want the weight to come from column E. All right. Okay. So E is fixed, 201 is free. So when you copy down, the weight will come from here for actual equal to 1. Okay. Then, all right. So now we can copy the totals here. And then the misclassification rate, so is 21.9. So this is the true misclassification rate after adjusting for the oversampling weights. So what we just saw in Excel, so that's what is reflected here, and the percentage of records predicted as 1 is 23.24.